Hello everyone, let's study about the Van de Graaff generator. Now this is a device which was devised by a scientist called as Robert J. Van de Graaff. This device is basically used to produce a potential difference of very high value, that is around 6 to 8 million volts. First let's understand what is its principle. So its principle is that if you have two spherical shells which are concentric, and if a charge is put on the inner spherical shell, and if these two are connected by a wire, then whatever charge is present in the inner shell would move to the outer shell. How much of a charge we put on the inner shell, the entire charge will move on to the outer shell, and that is its principle. So let's understand it in detail. So first, let's assume a case where a charge Q1 is put on the inner shell. Let its radius be called as R1 and the radius of the outer shell be R2. So we have two concentric spherical shells of radius R1 and radius R2. Let's assume a case where charge is put on the inner shell. Charge is called as Q1. Now let's assume that these two are connected by a wire like this. We know that the potential inside our shell or on top of the shell is equal to K Q by R. So let's take 2 points, a point somewhere here and a point somewhere here. Let the potential at this point be V1 and this point be V2. Let us call this point as point A and this is point B. So let's find out what is V1 first. So V1 is equal to, it will have two contributions because of the smaller shell and the bigger shell, but since the bigger shell has no charge, the contribution here is only because of the small shell and the point is on its surface. So it will be K Q1 by R1 because this point A is on the surface of the shell. The second sphere will have no contribution. Similarly, potential V2 would again be only because of this contribution, that is only because of the sphere 1, not sphere 2, because sphere 2 has no charge. And then the distance from this to this would be R2. I learnt in the theory classes that for a points outside the shell, this shell will behave like a point charge. Therefore, distance between the center to the point B would be R2. Its contribution would be K Q1 by R2. If we take difference of these two, that is V1 minus V2 is equal to K, it will be Q1, which is common factor. So it will be 1 by R1 minus 1 by R2. So the difference of potential V1 minus V2 is therefore given as KQ 1 by R1 minus 1 by R2. Now observe carefully here, since R2 is less than R1, so this term would be less than this term. Therefore, from here it is very clear that V1 is more than V2. For example, let's take R1 as 1 meter and R2 as 2 meter. Then what we get from here would be V1 minus V2 is equal to KQ1, this Q1 here, by 1 by 1 minus 1 by 2. That is KQ1 will be 1 minus half. And this term is more than this term. It's a positive value. Therefore, V1 is more than V2. Since the charge always moves from high to low potential, since V1 is always more than V2, charge Q1 will flow from shell 1 to shell 2. Let's take another case where there is a charge Q1 in the inner shell and a charge Q2 is on the outer shell. Let's find out what happens now. That is, if we assume that some part of charge goes from there, that is, if the charge starts to build up on the second shell, then let us find out whether that will make any difference to the answer. Again, here also let's find the potentials. Let's find what is V1 first. In this case, it will have both the contributions, that is, at the points V1 and V2, there will be contribution from both the shells. So V1 is equal to, for point V1, it is, that is for this, for V1, both the shells will contribute. Therefore, V1 is equal to, it will be K Q1 by R1 plus K. For the second shell, this point A is inside the shell. That is, for this charge is Q1 here, charge is Q2 here, this is point A, this is point B. For second shell, point A is inside the shell, it will be a constant value, so it will be K Q2 by R2. Let's find what is V2. Now V2 is the potential on the bigger shell. Again, this will have both the contributions, but from the first shell, the point B is away from the first shell. Therefore, the first shell behaves like a point charge. It will be K Q1 by R2 now plus K Q2 by R2, because for second shell it is a point on the shell. If we take difference of these two, then what we get is, that is, V1 minus V2 is equal to, it will be K Q1 by R1 plus K Q2 by R2 minus K Q1 by R2 minus K Q2 by R2. From this, system gets cancelled, and finally what remains would be, it is K Q1 by R1 minus K Q1 by R2. If we take K Q1 common here, it is 1 by R1 minus 1 by R2, which is what we got in the case when the charge on the second shell was 0, as seen here, which means always the potential difference would be greater between V1 and V2. That is, the charge will always move from the inner shell to the outer shell. Doesn't matter whether the outer shell contains charge or not, always charge starts to move from the inner to the outer shell. And this is the principle of Van de Graaff generated.